Okay, today we're going to take a look at Unit 1, Lesson 6 about inverse functions. You may have seen inverse functions before. Let me just start with a definition of inverses. Two functions are an inverse of each other. They're considered to be invertible. That's the word that we will use. And so inverses is very simply put just a switching of x and y. And what's really nice about that definition is it actually tells you what to do if a question asks you to find an inverse, is we're just simply going to switch x and y. Okay. The symbol for an inverse looks like this. So we've been talking about f of x, so the symbol puts a little -1 kind of up there in the exponent, and that's what it looks like when we say the inverse of the function f, and that's the symbol that we're going to use. Okay, so let me start with an example here. I want to find the inverse of f of x. So what I'm going to do is I'm going to leave a little room over here on the left to write down some steps that I'm going to follow to find the inverse, and then I'm going to do the example over here on the right. So a little bit different from what I usually do. But I'm going to put my steps over there on one side, and I'm going to do my example over there on the other side. Okay, so let me get an example here. Let's take a look at f of x is equal to 3x minus 1. Okay, so that'll be given to us. Okay, so in the first step, in step number 1, I'm going to go down here and say step number 1, I'm going to change f of x into y equals. Draw a line here so we can see the difference between our steps in our example. Okay, so I'm going to take this f of x out. I'm going to change it into y equals. So now I'm going to have y equals 3x minus 1. That's important because, again, our definition says that we're going to switch x and y, so I have to have a y to be able to switch with. So we're going to change that f of x into y equals. They mean the same thing. All right, let's go ahead and do our definition now. So next I'm going to switch x and y. Okay, so over here in my example, I'm going to switch x and y, so I'm now going to say that x is equal to 3y minus 1. Okay, and so technically that's the inverse, but that's not really the way that we like to look at them. So in step number 3, I'm going to go back and solve for y again. Okay, so solving for y on this one, I'm going to add my 1 over to this side, so that'll give me x plus 1 equals 3y. And then I'm going to divide by 3, and you can write this one of two ways. I like to just write it x plus 1 divided by 3 is equal to y. Okay, or you could say y is equal to x plus 1 divided by 3. Let me go ahead and write it that way, because that'll make our last step a little bit easier. Or if you prefer, you can write this as 1/3 x plus 1/3 is equal to y. So if you want to divide that 3 into both terms separately and write them separately, that's okay with me. Or if you want to write it all as one fraction, that's completely up to your choice. Okay, and so finally, in the last step, I'm going to use our symbol. So I'm going to write as our f inverse. Okay, so I'm going to say now, I'm going to take y back out. I'm going to replace it with f inverse. So the inverse of f is equal to x plus 1 divided by 3. And there's my answer. Okay. Or again, if you'd rather have f inverse of x is equal to, and write it this way, you can write it that way as well, your choice. Okay, let me give you another one, and I would encourage you to stop your video just for a minute and give this one a try, and then come back and check your answer. Let's take a look at f of x is equal to the square root of x minus 3. Okay, so pause your video just for a minute and give that one a try. Okay, so I'm not going to rewrite all of my steps. I'm just going to kind of go through them as we go here. So I'm going to start by changing f of x into y equals. And then in step number 2, I'm going to switch x and y. So that's going to give me that x equals the square root of y minus 3. And then I'm going to solve for y. So to solve for y, the first thing I'm going to do is I'm going to add this 3 over here to this side. And then I know that to get a square root off of a y, I'm going to square both sides. Okay, so I'm going to square both sides, so that's going to leave me with x plus 3 squared over here is equal to y. And I'm okay if you leave that x plus 3 squared like that. That's perfectly fine. You can square it out if you want to. Just again, don't forget that middle term. So if you were to square it out, it would be x squared plus 6x plus 9. So don't forget that plus 6x in the middle there. Okay, and then I'm going to change my y back into my inverse. So f inverse is equal to x plus 3 squared. So those two things are inverses of each other. Okay, let me take just a minute to show you how to prove that two functions are inverses of each other. So we talked a little bit the other day about composite functions, and so that's what we're going to use. So if we're going to prove that f of x and g of x are inverses of each other, we need to do two things. First, we need to find out that the composite of the two functions, so f of g of x, is equal to x. And I'm going to write that out, and I'm going to underline it twice because we have to do both. And we're going to prove that g of f, or show that g of f of x, is also equal to x. So they can't just come out to be equal to each other. They have to actually come out to both be equal to x. That's what's the important part. And again, we have to do both parts. Okay, so to prove that f and g are inverses, we have to prove or show both of these parts. Okay, so let's take a look at an example. I'm going to work with f of x being equal to x squared, and I'm going to work with g of x being equal to the square root of x. Okay, and you may already know that these are inverses of each other, because inverses is really the idea of if I'm trying to solve an equation and I've got x squared on one side and I've got, let's say, 9 on the other side, I'm going to do the opposite, or the inverse, and I must take the square root of both sides to get that x by itself. So it's kind of the basic idea of inverses, so you may be able to see that. All right, but I'm going to start by proving f of g of x is equal to x. And again, I like to rewrite that as f of g of x, like that. Okay, so I'm going to take my g of x out and replace it with g of x over here. So that's going to be f at the square root of x. So again, with those composites, we want to work from the inside out. And now I'm going to take this square root of x and I'm going to plug it into my f function. So now I'm going to have the square root of x squared. Okay, so that would be like x squared right there, which is what I have. And I know that my square and my square root cancel each other out, and I'm left with x. Okay, so I'm going to put a little check mark because step 1 worked. Okay, the first thing I need to do is prove that f of g of x is equal to x. And now I need to go back and do the other one. So g of f of x, and I need to make sure that it is also equal to x. Okay, so just a little different way of writing that. And I'm going to work from the inside out. So I'm going to start by taking my f of x. I'm going to replace it with x squared. Okay, now I'm going to plug this into my g function where I have x. So now I'm going to have the square root of x squared. And again, I know that square root and that square cancel each other out, and so I'm left with x. And so I know that f of x and g of x are inverses. Okay, so we showed the proof, and then we made our kind of conclusion statement there of because fog was equal to x and goff was equal to x, because their composites were equal to x, then I know that f and g are inverses of each other. Okay. The last thing that we'll do with inverses is trying to rewrite one function as a composite of two functions. Okay, so let me write that down. I'm going to write an f of x and a g of x so that my given function h of x is a composite such that h of x is equal to f of g of x. Okay, so what that's telling me is it's going to give me a function h, and I want to rewrite that as two separate functions, f and g, so that they originally were a composite where g was the inside function. Okay, let me show you an example of what I'm talking about. So I'm going to give you h of x. So h of x I'm going to give you is the square root of 5x squared plus 2. Okay, so we can give you any function there, and I'm going to call that h. Okay, and by the way, that square root and that square don't cancel each other out because we've got the 5 and the 2 acting with them. So be careful trying to simplify too much. Okay, so that one's not going to simplify. Okay, so what I'd like to do is I'd like to write an f of x function, and I'd like to write a g of x function. Okay, and because they set it up like this, I want g to be the one on the inside of something else. Okay, so in this case, g is going to be my function that is literally inside of my square root. So I'm going to let g of x be 5x squared plus 2. Now I'm going to take that out, and I'm going to replace it just with x. Okay, so I've still got my square root. I'm going to take all of this out, and I'm going to replace it just with x. So now, if I were to put it back together as f of g of x, I would say that g of x is 5x squared plus 2, and I would plug in this into my f function, which gives me back the square root of 5x squared plus 2. Okay, so this is just where I went back and kind of checked my answer. Okay, this is going to be really important when we get into calculus. In class the other day I talked a little bit about the chain rule. This is also going to be a part of the chain rule when we're talking about derivatives in calculus. So again, pre-calculus, all kind of leading to these calculus concepts. Okay, let me give you one more. Again, I encourage you to pause your video for just a minute and give this one a try. Let's say that h of x is equal to x plus 7 to the 4th power. Move that up so you can see it a little better. Okay, pause your video just for a second and give that one a try. Okay, so again, I'm going to write two functions. I'm going to write an f of x, and I'm going to write a g of x, and I want g of x to be on the inside. Okay, so I've got parentheses on this one, so I'm going to say that my inside function is this one right here, x plus 7. Right, so those are inside parentheses. So a lot of times it will literally be something that is inside something else, like inside a square root or inside an absolute value, or in this case, inside parentheses. Okay, so I'm going to take that out, cover that up. I'm going to replace it with x, and so that will give me x to the 4th. Okay, and I may have had something like added or subtracted on out here, like maybe a minus 2 out here, so then that would give me x to the 4th. Minus 2. That minus 2 would not be affected. Okay, so let's go and check and make sure if we put them back together that we end up with f of g of x. Okay, so g of x is x plus 7. I'm going to take out the x in f of x. Ignore that. I'm going to take out the x. I'm going to replace it with x plus 7, and that will give me that to the 4th power. And so it did. It checked out. Okay. All right, so give that worksheet a try. If you have any questions, be sure and let me know. See you later.